Hi, welcome to 8.1, Introduction to Trigonometry and the Tangent Ratio. I had a couple issues off the ground. This is about the fourth time I've done this intro, so let's see if I can get it a little bit more time. Trigonometry would be nice. It feels like we've been doing linear systems for quite some time now, and here's a bit of an opportunity to mix it up a bit. It's not really your introduction to trigonometry because you should have in the past looked at a couple of things which I'll review now. If these don't sound familiar to you, that's okay. So come up enough in this unit that even if you didn't pick up on them in previous classes, we should get them this time. So to start with, let's look at a right angle triangle. These might not be the best, but we're going to have to get used to me drawing not very good right angle triangles. It looks like I might be getting a little bit better. What we want to do, let's talk about this little symbol here. That little square in the corner just means that that's a right angle triangle, which just means 90 degrees. Just about all of the triangles we look at in this chapter will be 90-degree triangles. So if I forget to draw the little symbol in the corner, it's usually 90% of the time meant to be a right angle triangle anyway. Non-right angle triangles shouldn't be close. I'm not trying to trick you in any way. So what I'd like to talk about is the relationship between the three angles in a triangle. I'm going to use some different symbols instead of like X, Y, Z. Usually or frequently when we talk about angles, we use Greek symbols. The first one I drew that looks like a fish is an alpha. A fish that looks like it's driving straight down is a gamma. And this one in the top left-hand corner is called a theta. It doesn't really matter that you know what the names of those are. It doesn't even really matter if you can draw them or not. If you keep doing math, you'll see more and more of them. And they're just because we kind of ran out of the 26 letters in the English alphabet, so we started using more different ones. We frequently use the Greek letters to indicate angles, and then we'll use X, Y, Z, A, B, C to indicate length. So the relationship between the three angles, alpha plus gamma plus theta, if I was to add all three of those up, I would get 180 degrees. The angles in a triangle add up to 180 degrees. This is true for right angle triangles, and it's also true for every other type of triangle. If you have a triangle, all of the angles, if you add them all up, will equal 180 degrees. In a right angle triangle, in this case we've got an alpha, we know that gamma here is 90 degrees plus theta is equal to 180. I can rearrange this a little bit, subtract 90 from both sides, and I get that alpha plus theta is equal to 90 degrees. So if we have a right angle triangle and we know one of the angles, so if I know alpha or theta, then I could find out what the other angle is, because I would have one equation with one unknown, which we've just talked about a lot in linear systems. If you have one equation and one unknown, it's completely solvable. And that's one of the things that you guys should have seen before in the past, but again, we'll talk about it enough in this chapter that if you didn't pick it up in the past, that's fine. The other thing that we're going to talk about, and this is a tool that people have in their toolkit, the people were actually quite excited about seeing it again because they saw success with it last time they saw it, which is awesome. So I have another right angle triangle, and this time I'm going to call it ABC. So I saved my ABCs for this one because we're going to talk about the Pythagorean theorem. And that is A squared plus B squared is equal to C squared. And that's the relationship between the two sides next to the right angle in the right angle triangle and the hypotenuse. So C is the hypotenuse. And this is going to turn out to be super useful, not necessarily today, although it will come up today, but or not today in this lesson, but also in the next lesson. So in this case, C is the hypotenuse. C is equal to the hypotenuse, which we will frequently use the symbol capital H for. And H is, the hypotenuse, is always the longest side in a right angle triangle. always. So if there is no right angle triangle, if you're just looking at a triangle that's not a right angle triangle, you don't usually have a hypotenuse. And it is also always opposite the right angle. Notice how these two legs are right beside the right angle, and the side opposite is the hypotenuse. The hypotenuse will always be opposite that right angle. And that we're going to need to know for today. So what we're going to look at today in our introduction to trigonometry is ratios. So a ratio is just one number divided by another number. So what I have here is I have three right angle triangles. I've got a little one. I've got a medium-sized one. And I have a larger one. And what I would like to look at, there's my big one. What I would like to look at is the ratio of my opposite side and adjacent side. So if I look from this angle, and maybe I'll make that a little bit brighter, maybe I'll put that purple in there just so we can see it a bit more. We're going to look at that angle. That would make these our opposite sides. And since my long side is my hypotenuse, that means that the other side next to it, notice how this angle is next to that, and this angle is, so this bottom one is my adjacent side. So I actually have three adjacent sides along here, but I'm just going to write one because they're all kind of overlapping. And now I can't remember where that ruler goes, but we'll do our best to kind of stick it back where it went and line it up. That should be pretty close. I don't know how opposite side and adjacent side. So we're going to go over this more so that you guys can practice labeling triangles. But for now, I just want to point a couple of things out. What we're going to do is we're going to measure these three opposite over adjacent ratios. So if I look at that big triangle, I can take this ruler, I can slide it up, and I see that my opposite over adjacent ratio for my big triangle, maybe I'll label it big, is going to be about, this is off a little bit, I'm going to have to move it up, sorry, to be moving it around. Oh, let's see. If I line the bottom up with the bottom of the triangle, it should be at about 3.3. And I can see that the length of my triangle is at about 12.7. If I go ahead and plug that in my calculator so I get a decimal, I get 3.3 divided by 12.7, and I get about, that went away a bit too fast for me, a 0.26. I'm just going to round a little bit, 0.26. If I look at my middle triangle, my opposite over adjacent ratio, and now I'm going to have to move my ruler over and see if I can get it in the right spot. I should get about, from bottom to the top of that triangle, about 2.3 divided by the length of that triangle, which is about 8. Oh, I think my rulers, I wrote down what it should be, but it's a little bit off right now. It should be, come on. If I line my 0 up with the edge at about 9, 2.3 over 9. If I go and I plug that into my calculator, I get also 0.26. This demonstration looks a little bit better if you guys all have your own rulers, your own right angle triangles, and you measure them yourself. But we're still going to do the best we can do. And now if I look at my small one, my opposite side, looks like it's right between the 1.6 and the 1.7. So it looks like about a 1.65 divided by a 6.3, which if I type that into my calculator, you might be able to anticipate the answer, 1.65 divided by 6.3, and that is also equal to two sig figs, 0.26. So notice how our ratios are all the same. Oh, I don't need an apostrophe there. Are all the same. And that's true of any triangle with that same angle. So what I could do is calculators have an ability, since that ratio is related to the angle, a calculator has the ability to look up the ratio and tell me what the angle is. So in this case, it's a tangent ratio, and I'm going to write this down on the next page, so don't worry about it quite yet. My tangent ratios. What I can do is I can use my calculator. I'm going to clear it, and I have this tangent button, and if I hit Shift tan 0.26, so tangent is the type of ratio, that's my opposite over adjacent ratio. 0.26, I'm telling the calculator that I have a tangent ratio of 0.26. What is the angle? If I hit equal, it'll tell me it's about 14.5 or 14.6 degrees. So if I check, I can grab my little protractor here, and I'm going to see if I can get rid of this green stuff so that I can see this a little bit better. And if I drag my protractor over, and I place it properly, maybe I make it a little bit bigger so that we can see it. I find that it's about exactly that. So if we had proper rulers and they weren't mucked about a bit on a piece of paper, we'd actually get much closer and a little bit better result. But that's pretty close. So let's talk about this method of ratios. So the ratio opposite over adjacent is called the tangent ratio. So the first thing we're going to need to do when we are looking at a right angle triangle, and this is my right angle triangle, is label it. If this is my unknown angle, or if this is the angle that I'm looking at, let's give it a symbol. Theta is really common when we talk about angles. The angle opposite my right angle, and this is usually the one I look for first, is my hypotenuse. The angle, the side opposite my angle is my opposite, and then the one that's attached to the angle that isn't the hypotenuse is my adjacent. So I could ask questions like, find the tangent of the following. And I could give you guys some right angle triangles, and I could label an angle, and I could say this is a 5 and this is an 11. And so now you have to find out what the tangent of that theta is. Tangent is frequently shortened to tan, just about always. And what I'm saying is I'm going to find the tangent of that angle, theta. So the tangent of theta, so we're going to have to label our side, opposite the hypotenuse. The other side right next to my angle is going to be my adjacent, and the other one and the one opposite my angle is going to be opposite. So the tan, maybe I'll do this whole thing in red, the tangent of theta is equal to opposite over adjacent. And that could be a final answer. That would be the tangent ratio. That also figure out as a decimal, which we might do. This is another angle. I've called it gamma. So we could also find the tan of gamma. Notice how now I'm going to get rid of these red ones. My sides change. This is still the hypotenuse. My right angle did not change, so it's going to be the hypotenuse. But now 5 is the adjacent and 11 is opposite this angle. So the tangent ratio for gamma is going to be opposite over adjacent. 5. If I wanted to now, I could look up what those angles are. And this is the tricky part. Well, it's not tricky, but everybody's calculators are different. So notice how when I brought up my calculator, I have, and I don't know if you get how well you can see this, but I have this sine, cosine, tan. So this is my tangent button. And what tan does is tan, if I use the tan and I want to type some degrees in there, say like a tan of 40 degrees, it'll tell me what the ratio is. But right now I have the ratio and want to know the angle, so we have to use the inverse tan. So I'm going to hit Shift, inverse tan, and I want to know 5 divided by 11. And this would tell me what that angle is, 24 degrees. So I got some diagrams of a couple of common calculators, calculator page, and I want to show you guys how to find it on your own calculators. If you can't find it on your own calculators, let me know. And all I have here is a couple of common ones. So you just send me a picture of your calculator, I can tell you how to find the inverse tan. So again, what we're going to notice, and I'm just going to use this big one right here. I think it's, what is it? It's a Casio. I've got 2 Casios. I've got a Sharp and a Texas Instruments, and I'll make some of them bigger and smaller as we go through them. You'll notice that I have my sine, cos, and tan buttons right here. What we're going to focus on is the tan button for right now. And up above it, I've got this in yellow, tan to the -1. And that's what I want to do to find an angle. To find an angle, I'm going to use the inverse tan. And notice how it's this color yellow. So what's written on the button is what you get if you push it. But if I want the yellow thing, there's probably going to be a yellow button somewhere on this calculator. And on this one is a shift button. So if I hit shift and then tan, it'll give me the inverse tan. If you follow that same train of thought, there's also a red alpha, and notice how most calculators have some letters on them as well. It's not relevant, but that's how you would access those functions too when you get around to learning what those are. If I look at this Casio, it's probably going to be very similar because it is the same brand. And we'll notice how that, yeah, it's quite similar. I've got the same sine, cos, and tan buttons right here. These are the 3 primary trigonometric ratios. We'll talk about all of them, but right now, again, we're just focused on tan. Right above tan is this little yellow. And in order to access that little yellow one, we're going to hit that shift up there. I'm going to shrink this just so that I can enlarge my Sharp, because it'll look a little bit different. Come on, Sharp. Just move you up a little bit. On a Sharp calculator, we have the sine, cos, and tan right here. And we'll notice how that right above the tan button is the inverse tan in yellow. And this time it's not called a shift button, it's called a second function button. So I'd hit my second function and then tan, and that's how I would get access to that inverse tan. My Texas Instruments, this is kind of cool. I'm just going to drag it a bit bigger. So again, we can see Texas Instruments, we will see dead center. This is a very common calculator for those that are going into pre-calc 11 and 12. Most of you will use this. You will use it a bit in Foundations 11, I think, or Foundations 12. One of the two classes uses it quite heavily, and I don't think the other one needs it as much. But here in the middle, we have a sine, a cos, and a tan button as well. And this is time up above the tan is a blue inverse tan. Tan is a -1. And there's our second function and how we access it. So that was a lot about how to and why things work. And what I would like to do next is I'd like to just focus on some example questions. Most people don't really understand how the tangent ratios work or why they work, but many, many people can use them. So let's do find the tangent ratio of the indicated angle I'm going to draw some triangles. We're going to do an A and a B, and this time I'm just going to use a question mark. I did that way, so let's do this way. And then I'm going to do this angle. And let's put a 7 here, and this side looks a little bit smaller, so we'll put a 6 there. And then on B, let's put a 13 here and a 14 there. So for A, if I'm just trying to find the tangent ratio, I'm just looking for the tangent ratio of whatever that angle is going to be equal to my opposite over adjacent. The equation, tan theta is equal to opposite over adjacent, is worth knowing, and sometimes will be given to you on a formula sheet. Well, we've done all three, sine, cos, and tan. I'll show you a bit of a memorization trick. But yeah. So my tangent ratio, again, all we have to do is label my sides. Angle opposite, or sorry, the side opposite is the 90 degrees is always my hypotenuse. And then I'm going to label my other two. Oh no, where'd I end up going? Oh. I'm going to label my other two. I think that was a 6, and I don't know why it's not there anymore. My other two, so my side opposite, my angle is my opposite, and the side right next to it is my adjacent. So my opposite over adjacent is just a 7 over 6. Tan on my unknown is 7 over 6, and that's our final answer. People get really fast at these. You don't necessarily have to write down opposite, adjacent, and hypotenuse every time, but to start with, I recommend you do. Again, I'm not trying to trick you. I just forgot to put my 90-degree symbols in. There we go. So from this angle, the side opposite is opposite. The side right next to the angle that's not my hypotenuse is adjacent. So for this triangle, my tan is equal to opposite over adjacent. And those are my two tangent ratios. I should probably have written down the formula above it and then substituted my values in. It's pretty good practice. Let's look at a couple more examples. Find the measure of the missing angle, or of the indicated angle. Draw a triangle that and I'm going to put my 90 degree there, and I'm going to call this my missing angle with a question mark, and I'm going to call this a 4, and this a 9, and this an A. Let's do this one first before I write down the second one. So I'm looking for my opposite side and my adjacent side so that I can use the tangent ratio is equal to opposite over adjacent. I'm not a fan of the question mark, so what I'm actually going to do is I'm going to change it to an X, and then we can just focus a little bit more on the algebra because it looks a little bit more about the algebra. So I've done most of the mathematical understanding already. Tan of X is equal to 9 over 4. I've applied the equation, which again I should have written down first. So again, of theta is how it would be given, is equal to opposite over adjacent, is equal to 9 over 4. So what I've tried to focus really hard on in this class is that all algebra is the same. So if I know what X is, I have to get it all by itself. So in order to get rid of the tan, I have to do the opposite of tan. So this is the same as the opposite of multiply is divide, and the opposite of add is subtract. So the opposite of tan, though, is just inverse tan. So I can take the inverse tan of both sides of my equation. And inverse tan of tan cancels, so I'm just left with X. And then my right-hand side is inverse tan of 9 over 4. So I can open up my calculator. I'm going to clear everything that was in there. And I'm going to hit Shift, because that's how I do it on my calculator. Inverse tan. On most calculators, it won't say a tan. I'll just say tan with a little -1. And then I'm going to type in that little ratio that I already have, which is 9 over 4. Close my bracket, hit equal, and I find that my missing angle is, I went too fast for myself again, 66 degrees. So it's just an algebra problem, except now you know one more function. You know, add, subtract, multiply, divide, brackets and exponents, and now we're starting to look at trigonometric ratios. So let's look at B. This one is going to be very similar. I'm going to do a right angle triangle. I'm going to make that a bit longer just for funsies. And we'll call that side 3, we'll call this side 9, and I'm going to look for this angle, which I'm going to call it X. So label our triangle. 9 is the opposite side, 3 is the adjacent side. I only know the tangent ratio, so I'm going to use tan of theta is equal to opposite over adjacent. In this case, our theta is an X. My opposite is 9. My adjacent is 3. I want to isolate X, so I'm going to take the inverse tan of both sides. And that's equal to the inverse tan. What I do to one side, I must do to the other side, of 9 over 3. And again, I can plug this into my calculator. The inverse tan of tan is just X. They cancel. That's why we do that. So then I can go to my calculator, and I can type in the inverse tan of 9 over 3, and that's equal to 71.6 degrees. And that's how I would find that angle. I'm not sure why I wrote X equal to and then a theta is equal to that, 66 degrees right there. And that's how I would find a missing angle. So what you can also do, just because there's a couple of different modes for calculators, what you should be able to do, a good one is to type in maybe the tan of, what's the tan of 30? Is that a nice one? Oh, I have to finish my expression. The tan of 30, no, let's do the sine of 90. So the sine of 90 should equal 1. If the sine of 90 is not equal to 1, your calculator is in the wrong mode. So mine right now is in degrees mode, which is what we want, but there's a couple other modes that your calculators could be in. If you type in the sign of 90 and it does not equal 1, you might have to take a picture of your calculator and send it to me, and I'll tell you what buttons to push to get it into degrees mode. Let's look at how to find a missing side. So, let's do this. Let's give it an A. I'm going to call this side X. Let's give this a side, I don't know, 5 seems like a pretty good number. And let's call this a 33 degrees. Again, we are going to use the tangent ratio, and it's equal to opposite over adjacent. I'm going to substitute all of the values in. I know it's the exact same process as above. In this case, my tangent ratio, I'm looking at a 33 degree angle, and it's going to be equal to my opposite side. Oh, what's my opposite side? I haven't labeled my triangles yet. Opposite is going to be this one over here, and my adjacent is going to be this one. It's the one right next to it. So my tan of 33 is going to be equal to x divided by 5. Tan 33 shouldn't panic you. It's just a number. If I go into my calculator and I type in tan of 33, it'll tell me what the ratio should be for a 33 degree angle, and it's 0.649. With some extra decimals, which I'm going to put the ellipses there, the dot, 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 so that I tell myself and whoever's coming after me that what I have is more decimals than I'm storing them in my calculator, x over 5. And now all I have to do is I have to isolate x. Exactly the same as what we've done for everything else for algebra. To get x all by itself, I'm going to have to multiply both sides by 5. On my right-hand side, it cancels, and I'll have x isolated. So I can go back to my calculator and say, okay, I'm going to have this really long decimal, and then I'm going to multiply it by 5. And what I can do on my calculator is most will have this little button here called answer. So I'll hit an answer, which will take my previous answer, and multiply it by 5. That is equal to 3.247. So what I do by using that answer button is it allows me to use all of the decimals for my previous answer without having to write them all down or type them all back in again. Let's do a second one. I am going to do a triangle this way because I'm not sure if I've done one this way yet. We're going to call that a right angle triangle. I'm going to call this, let's do a 27 degrees, and let's call this, I don't know, an 8. And now I'm looking for x again. So I've got the exact same equation. Tan of theta is equal to opposite over adjacent. I'm going to go ahead and label the sides of my triangle. The side opposite, let me do that in a different color. The side opposite is opposite. The side right beside is adjacent. So that tan, substituting all the things in I know, of 27 is equal to opposite, which is 8, over adjacent, which is x. So you'll notice that my x value isn't in the same position as it was before. It's now on the bottom of a fraction. If it's on the bottom of a fraction, we cannot solve for it. So what we're going to have to do, and tan 27 is just a number. And I'm just going to remember that tan 27 is just a number, and I could write it down as a bunch of decimals, or I can just leave it as tan 27. I can multiply both sides by x. On my right-hand side, I have x divided by x, which is 1. On my left-hand side, I have x tan 27. Tan 27 is just a number. If it makes you uncomfortable, I can even look it up right now. The tan of 27 is just a ratio. It is 0.509. I'm going to ignore that for now. But it's just a number, so I can divide both sides by a thing that's just a number. Easier for me to write down tan 27 than those decimals, but if you want to do the decimals, you go right ahead. On my left-hand side, number divided by the same number is 1. On my right-hand side, I have 8 divided by tan 27. I'm going to go into my calculator. I'm going to do 8 divided by, I just did it so I could do answer again if I wanted. 8 divided by answer is at 15.7. and that would be the length of side x. It's probably then worth, since I've been using that answer key, to go back to my calculator page and show you that that answer button exists on all of these calculators too. On this little Casio over here, which is quite small, it's down there. Maybe I'll do that in a different color so that you guys can actually see it. It's right there. On this Casio, I bet if I move it up, it's going to be bottom right-hand corner because that's where it was on the other Casio. There it is right there. I'm just trying to erase those red things that now aren't necessarily in the right spot. You'll notice on this TI-84, it's in blue right here, which means you're going to have to hit the second function and then this button, which will give you that answer. And on this sharp over here, it's a huge button right there.
Thank you for watching, and I just wanted to remind you guys a couple of keys for success. Number one, you got to do the practice questions. If the things I'm saying make sense, that's phenomenal, but you still have to practice and make some mistakes on your own. And that goes along with number two. If you get stuck, ask me questions, get in touch, write me an email, make an appointment, or leave a comment on the YouTube video. And step number three to success is look after yourself. Eat good food, get some exercise every day, and socialize as much as you can right now. I hope you guys are all doing well, and I will talk to you soon.